Welcome back to Math Maintenance. Today we are talking about quadrilaterals. So the big term quadrilateral has the word quad in it, and quad means four. So the big term quadrilateral just means any shape with four sides. These could be the regular ones like we're used to seeing, or they could be some really abstract, wonky things. That have four sides. So as long as it has four sides that come together into four vertices or points where those sides meet, it's considered a quadrilateral. And since quadrilateral is such a broad term, we use other terms to help narrow down and give specific examples or specific qualities to those quadrilaterals. The first one we're going to talk about is a trapezoid. A trapezoid is a special kind of quadrilateral, so we know that it's going to have four sides and we know that it's going to have four angles. The special quality of a trapezoid is that one of those sets of sides has to be parallel. So two sides of a trapezoid have to be such that if you continued them forever and ever and ever in both directions, they never touched. The other two sides of that trapezoid can't be parallel. So they can't be straight up and down. You would have to have something maybe like this. So you have exactly one set of parallel sides in a trapezoid, and the other set of sides don't get to be parallel. They have to be something else. A parallelogram, on the other hand, has to have two sets of parallel sides. So for example, if this set of sides is parallel, this set of sides also has to be parallel. A rectangle is also a parallelogram because it has two sets of parallel sides. A square is also a parallelogram because it has two sets of parallel sides. So a rectangle is a parallelogram, but not every parallelogram is a rectangle because in a rectangle we have another special trait. So two sets of parallel sides. We also need four 90-degree angles. So a rectangle has two sets of parallel sides, and all the corners have to be 90 degrees when you get to them. A square is an example of a rectangle because it has two sets of parallel sides and four right angles. However, not every rectangle is a square because in order to be a square, we get one more special trait. So a square is the most specific because it needs two sets of parallel sides. It needs four right angles. It also needs four equal sides. So the length of the sides in a square have to all be the same length. So a quadrilateral is the broadest term. It encompasses odd things and also the more regular things that we're used to seeing. Trapezoids are kind of a special case because it just has one set of parallel sides and the other set is doing its own thing. Parallelogram starts to get a little bit more specific because two sets of parallel sides, but you can see that we still have quite a few things because we can tip them and turn them different ways. Rectangle gets a little bit more specific, but we still have a couple of things that fit in there. And then square is the most specific. It has the most rules for that shape. In your packet today, you have this page called Quadrilateral Classification. What you're going to do is look at the shape on the page, read the word inside that shape, and if that word is really a name that we could call that shape, you're going to color it in green. If it's not classified correctly, you'll color it in orange. Your digital practice for today is not actually about quadrilaterals. It's practicing looking at two sides of a mathematical expression and deciding if that expression is true or false. For example, one side might say something like 100 plus 8, and then the other side might say something like 20 times 6. And you need to figure out whether that expression goes in the true column or in the false column. Your manipulative practice today is to practice your multiplication flashcards. Multiplication is such an important skill in so many different parts of mathematics that getting those facts down really, really solid and fast and accurately will only help you moving forward. Best of luck.